This video will be on the parent function test that you all just took. So let's get started with this. The very first one, we are given just a general function f of x, and we're given a t-chart with f of x. And then we're also given down here, we're given some kind of transformation to do with this general function. So notice that back in Algebra 1, let's review just a little bit. We were told back in Algebra 1 that instead of writing y has been changed to be f of x. So notice, if we think about that, then all of my x values, which is on the inside, all of those x values are going to stay the same. There's no transformation going on inside the parentheses. So automatically from this, I know that all of my x values will be -3, -1, 1, 3, and 5 for my new function. Now for my next part, for the y values, notice what this is saying. We are going to change the sign of y. So that's the first thing we'll do, is change the sign of y. Then we will add 2. So again, think about your order of operations here. And so the second thing again, then add 2. So let's go through and look. What are all my y values? Well, right here's all of those f of x values. That again is also what's written through here. So let's go through and change the sign of y and then add 2. So if I change the sign of 5, that becomes -5. And then if I add 2 to that, that becomes -3. So my new ordered pair on g at x is -3, -3. Now let's look at the next one. So again, same process. We're going to take 1. We need to change the sign of 1, so that's going to make that -1. And then I'm going to add 2, so that makes a +1. So that in turn tells me that I have the ordered pair -1, 1. And if you continue this process, again, let me do just one more, make sure we have it. And again, we're going to take our y value, which is -4, but again, we are changing the sign of y. So -4 now becomes +4. And then I add 2 to that, so that gives me 6. So I have the ordered pair 1, 6. And again, the same with 1. Change the sign and add 2. So that's going to give me the point 31. And then finally, the last point, which should be 5, 0. So again, I knew I was changing the sign of y because f of x took the place of y back in Algebra 1, but we do need to review that. And then with this notation here, that means the opposite of y, or we're changing the sign of y. All right, let's do another one. Again, same idea, but now we've got a little bit different for our transformations. So let's see what's happening. If we start with the x value, with x, notice that on the inside here, we would have to make our transformation from our parent functions. We were told that we need to move right 2. In other words, I'm moving all of my x values to the right 2. Well, if I'm moving to the right 2, then that's going to imply that all of my x values, I need to add 2 to all of the x values. So let's look at our chart and fill that in. If I take these known x values for f of x and I add 2 to each one, that's going to give me a -1 here. And again, if I'm adding 2, I get +1, 3, 5, and finally 7. All right, now let's look at the y transformation. What's going on with our y coordinate? Well, with the y coordinate, again, remember I need to change the sign. That's what that negative means. So we're going to change signs. And then what would we do after we change signs? We would then add 2. So very similar to what we did earlier. So look at all those y values. I'm going to change the sign. So right here, all of our y values. We're going to change the sign of 5, so that makes that -5. And then I'm going to add 2. So -5 plus 2, that's going to be -3. And if you notice, this is the same process as the previous question. So again, we are going to change the sign of 1, so that means -1, and then add 2, so that gives me +1. Again, if I change the sign of -4, that becomes +4, and then I'm adding 2, so that becomes 6, and then the next one 1, and then 0. So from here we have some points that we can rewrite. We have the point -1, -3. We have the point 1, 1. We have the point 3, 6, 5, 1, and then finally 7, 0. Okay, for the next part on your test, you had to find certain values. And the important thing here was for you to realize what the notation wanted you to do. So in other words, for part A and B, if 8, notice here, is on the inside of the parentheses and 0, then that means you're plugging on the inside. Oh, we can't see that color so good. Let me swap colors right quick. So right here, that's going to go on the inside. Same is true here. It will go on the inside. So that means if we're trying to find the value of h at 8, then that means I have the square root of 8 plus 1 and then minus 4. I'm just substituting in. So then that implies that I have the square root of 9 minus 4. And so that's going to give me a value of 3 minus 4, which is -1. So I have the ordered pair 8, -1. That's what I found is a point on that graph. All right, so for the next one, h at 0, it's going to follow the same method. So we need to plug in 0. So I would have 0 plus 1, then minus 4. And so that's going to give me 1 minus 4. So I'm going to get -3. So the ordered pair that I found is -3, 0. Now the next notation, notice where the value is that they want us to plug in. This value is on the outside, so it's telling us to take our function h of x and make it equal to 2. So in order to do that, our function for h of x is going to be the square root of x plus 1 minus 4, and that's all going to be equal to 2. This is my h of x right here. That's the value of h at x. So I'm just replacing h of x with the actual value that it was given. Now to solve for x, we would have to add 4 over. So I have the square root of x plus 1. That's equal to 6. Now to remove a radical, you do need to square both sides. So I have x plus 1 equals 36. So then solving for x, that's going to give us 35. So we have the ordered pair 35, 2. Now the same idea over here on the other side. Again, we're going to take the square root of x plus 1 minus 4, and we're going to set that equal to 0. So we would need to add 4 over. And so that's going to give us, let's see, we need to square both sides. And so we would have x plus 1 is equal to 16, so x is 15. So the ordered pair that we found is 15, 0. Okay, our next part, we were told to find the domain and range of our given equation. Now I'm going to write the equation, then graph it, then come back and state the domain and range. Now our original function we had was h of x equals the square root of x plus 1 and then minus 4. Now when we graph this, let's look over here at what our parent function is going to do. We do need to start at 0, 0. And from 0, 0, on the inside, that means we need to move left 1. So I will need to move left 1. And then from left 1, I need to go down 4. So left 1, down 4. So there's going to be where I start out with. Now let's think about some of the other values we found. Look up at A, B, C, and D. So those are values on my graph. So if I look back up at A, I know the value 8. So we have 8, -1. That's a point on my graph. Also, we had 0, -3. Again, another point on my graph. And let's see, we had 35 too, but that is just clearly going to be craziness. And then finally, the last one we had was 15, 0. So we're going to go over and graph 15, 0. So we have that. All right, so now we have a good map of what this graph should look like. So here we know what that parent function should be. And so here we have a good graph of this. And with the graph, it's always a lot easier to state your domain and range. So how does my graph justify your answers in parts A, B, C, and D? Well, they're part of your graph. Those are points that you are finding on your graph. It makes sense. Now, this question was trying to get y'all to realize that if we did a graph, if we were plotting those points and paying attention to what we found, if we got a point somewhere over here, or way up here, or way down here, we should realize that that's wrong. So we need to use our graph to justify some of our answers. All right, now for the next part, I'm going backwards here, we need to state the domain and the range. So if we state our domain and range, then let's look and see how far, let's go ahead and do the domain. So domain is how far left did my graph go? Well, as far left is -1. That's going to be right there. Now, how far right did it go? Positive infinity. Okay, so what about the range? How far below the y-axis did my graph go? Well, it went all the way down to here, which is going to be -4. And then how far above did this go? Well, it didn't stop. So it's going to be to positive infinity. All right, for your free response non-calculator portion, we had to find these values that we were given. We had to use our piecewise function. So let's go through and look at what would be the value of p at -2. Well, p at -2, if we go and we need to find, well, what interval would -2 fall into? And notice -2 should fall inside this interval here between -5 and 0. That's where you'll find -2. So that tells me this is the function I need to use when I'm evaluating this. So we're going to have -4, absolute value. Well, -2 plus 3, that's going to be a +1 plus 5. And so this value here gives me 1. So I've actually found the value -2, 1. All right, so let's look at the next one. We needed to find p of 4. So let's go look and see, well, what would be the value of p at 4? Well, let's look. 4 is not between -5 and 0, so I can't use that interval. Now for this next one, we have x is less than 4, and here we have x is greater than 4. So nowhere is x equal to 4. So here we would write does not exist. And again, that's because nowhere did x could be equal to 4. All right, let's look at the next one, p at 2. And again, go find, well, what interval would 2 fall into? And it should be the second one. So that tells me I need to plug into that function. So I'm going to have 1/4 times 2 minus 1. And some folks left it like this and said they could not solve that. And so I encourage you to learn how. You can put 2 over 1, and you can cancel the 2 and the 4. And so that's going to leave me with the fraction 1/2 minus 1, which hopefully will generate a -1/2. If you have 50 cents and you owe someone $1, you still gonna owe them 50 cents. All right, and so what ordered pair did we generate from this? We generated the ordered pair 2, -1/2. All right, and then for our last value, we needed to find P at 9. And so again, go look and see, well, where would 9 fall? Well, 9's not between -5 and 0, or 0 and 4, and 9's not even between 4 and 8. So this is going to be another value that would not exist. Okay, for the next part of your free response, you were asked to sketch P of x. So we've got to sketch this piecewise function. So let's take the first part, and I would do a t-chart. So we have x, we have P at x, and now let's look at the first endpoint. I know x can't be equal to, so here when we sketch that point, we will do an open circle, and when we plug in -5 right here to that part and work it out, you should get -3. And then we're going to do the other endpoint. Let's plug in 0, and once we plug in 0, we should have -7. So if we over here on the other side, we go ahead and plot those two values. So I have -5, -3. So let's get that point plotted. And then we also have the point 0, -7. So 0, -7. Uh-oh, I've already made a mistake. Oh, doo-doo. Let's see, -5, -3. It was an open circle. Oh, dear. All right, and then 0, -7 was a closed circle. Yep. All right, so let's think about our parent function transformation here. And I know these 2 points, I have to go through that, but to transform this from 0, 0, I would go left 3, and then I would move up 5. And so there's the vertex of this. We know it's flipped upside down because of the negative, and now we're going to connect our points. And so we're not going to put arrows at the end of this because this function is bounded by those endpoints. All right, let's go ahead and do the next one. So our next function, again, set up a t-chart. It does tend to make things a little bit easier, and it does organize your points. And so we are going to use 0, that's one endpoint, and we're going to use the other endpoint, which is 4. So now we're plugging into this value here. So if I substitute in 0, I should get -1. And if I use 4, then that's going to give me 0. And from this form, we know that we have a straight line. So this one shouldn't be too bad to graph. So I have the point 0, -1, and it is a closed circle because it can be equal to. And then I have 4, 0, which is an open circle. And then since this is a line, we know we just connect those 2 points. All right, and now for the last one, let me swap colors. For the last one, notice we have a parabola, and let's go ahead and do our t-chart for it. And we will also here fill in. We know I have endpoints 4 and I have endpoints 8, and so let's fill in. If I substitute in 4, then I should get the point 6, and if I fill in the point 8, then I'm going to get 6 again. So, oh me, we got some strangeness, but this is a parabola. It's supposed to make a U, so it's not completely wacky that it's like that. So let's look, and both of those are open circles. So we have 4, 6, so 4 and then up 6, and that's an open circle, and then 8, 6. Now we need a point in between because we do need to make our U, and that's where knowing our transformation is going to come from. So here, let's see, from the vertex of 0, 0, we need to move right 6 and up 2. So we would go right 6 and up 2, and now let's make a smiley face through those. All right, so there's going to be all of the different pieces of our piecewise function. All right, and now part C of your free response question asks you to explain how the graph in part B validates your answers in part A. And so the best way to say that would be that the graph in part B contains the points in part A. Very straightforward. Again, I just want you to realize that all of this notation, you are finding points on the graph. Now the last part, you need to state the domain and the range. So let's see, domain, how far left did we go? So as far left as we went was -5, and -5 was an open circle, so we need parentheses -5. And how far right did we go? Well, as far right that we went, it looks like we might have a break there at 4, don't we? Because both of those were open circles. So we have to break at 4 and then pick back up on the other side of 4 and continue all the way out to 8. Now, as far as range, how far below the y-axis did we go? And it looks like -7, and that's a for sure value, all the way up to, it looks like 6. I don't see any other breaks in the range. So all the way up to 6.